What's going on, everybody? It is Kistner again, and today we are talking about lesson 2-4 out of your book. And in your student companion, you can go ahead and turn to page 44. We're going to skip their little opening problem and go right into the examples. Now, the first thing that we're going to see, by the way, this is called complex numbers and their operations. The first thing that we're going to see here is how can you, this is not actually in your student companion. I kind of typed this problem in here to kind of show you guys where we're headed. How can you use square roots to solve the equation x squared equals negative 9? Now, we're used to seeing problems like x squared equals positive 9. And if we took the square root of this, we would end up with x equals, this is the way you're going to use square roots, by the way. Take the square root of both sides to cancel out the 2, the squared. X would equal 3 or negative 3. Can't forget that negative 3 squared is also 9. So the quick way to write this would be x equals plus or minus 3. There's a positive 3 or the negative 3, plus or minus 3. Now, when we do that to the problem it actually gave us, everything's the same except for the fact that we're going to break the negative 9 apart, because you've been taught over and over again that there is no answer to a square root of a negative number. You cannot take the square root of a negative number. You just say cannot do it. Does not exist. Well, now it does. We're going to break this down as if we're simplifying a radical. I see square root of 9 as 9 times the square root of 9 times negative 1. And if you remember your radical rules, this becomes x equals the square root of 9 times the square root of negative 1. You can break it apart that way. The square root of 9, once again, you should know, is plus or minus 3. And then we have just this square root of negative 1. And this is the way we would used to leave it if we were doing a problem like this. Or we would say that does not exist. Well, what you need to know is there is a square root of negative 1. It is I. Okay? I is the imaginary number. Or the imaginary unit is what your book's going to call it. That's the imaginary unit. So the square root of negative 1 is I. So another thing that we can get from this, and we'll use it later, but is that I squared is negative 1. But whenever you see the negative 1 or a negative symbol under a radical now, you can just write down I, because the square root of negative 1 is I. So our final answer here is going to be x equals plus or minus 3i. And that is our answer. So let's do the example that is actually in your student companion. Use square roots to solve each equation. Write your solutions using the imaginary unit I. So from this step, if I take the square root of x squared, I get x. If I take the square root of negative 5, it is going to be x equals plus or minus, well, there's 5 doesn't have a square root. So actually, let's get rid of that plus or minus for a second and break this down so we can see how to handle it. This is going to be x equals the square root of 5 times negative 1. And that's the square root of 5 times the square root of negative 1. Now, the square root of 5 doesn't have an answer. We don't know that answer, so we're going to leave it as a square root of 5. But negative 1 does. So this will be plus or minus I radical 5. The negative 1 became the I, square root of negative 1 became I, and the 5 stays the 5, and plus or minus because we're taking the square root of it. Now, you don't have to write this step every time. If you can just realize you're going to be bringing this out as plus or minus I, and then you just leave the 5 in there, that's fine. You can jump right to the answer. But this is showing me a little bit of work, and remember, showing me work is a good way to start showing me that you have mastered this and working towards that 4 and that 5, okay, on your standards-based grading. So here, I think, did I leave another part out here? Okay, so we're going to do part B in class, by the way. We'll do that one in class. Example 2, try it. We're going to be adding complex numbers. Now, complex numbers will be a plus or minus bi. That's the form of them. You have a real part and an imaginary part. The imaginary part has the I on it, the real part does not. So these are two complex numbers being added together. And we add them exactly as if they were real numbers. Remember, I is not a variable. I stands for, it's a number. It's the square root of -1. It's not a variable. So we can treat it kind of like a variable, but we have to remember that it is not one. So one way to do this is to say it's going to be real plus real. So the real part plus the real part plus imaginary plus imaginary. That is one way to add or subtract, which is what we're going to do on part B down here, numbers. So if we have -4 plus 6i plus -2 minus 9i, that's what this problem is, I'm going to add the real parts. So I'm going to add -4 plus a -2. So my work will look like this. -4 plus a -2, that's the real parts, plus the imaginary parts. 6i minus 9i. I'm adding plus a -9 there. So -4 plus that is going to be a -6 there, and 6i minus 9i is going to be minus 3i, and this is your answer. -6 minus 3i will be the answer to this problem. So we added the reals, the -4 and the -2, add those together to get -6, and we add the imaginary parts, 6i plus a -9i gives you a -3i. We will do the subtraction problem in class together because there's a little bit of a trick to that one. Write each product in the form a plus bi. So now we're multiplying complex numbers. And we, remember, I is a number. I is a number here, so we can just distribute this like it's a real number. It's not a real number, but we can distribute it like it is. So when I do this, I'm going to have 2/5 I times 10 minus 2/5 I times 5/2 I. That's just the distribution that I've done. 2/5 I times 10, 2/5 I times -5/2 I. So if we do this, the 5's cancel with that. That leaves me a 2. So that's going to be 4i. Okay, because that becomes 2. 2 times 2 is 4. Minus, this cancels and this cancels. So it's going to be minus I squared. So this is like this right now. This has got parentheses around it like that. Now, one thing that we need to, that I said I was going to bring back later that we need to know is that if I equals the square root of -1, we could square both sides, and the square root goes away. I squared equals -1. That is important to know. I squared equals -1. You should know both of these statements. That I is the square root of -1, and I squared by default would just then be -1. So what I have over here really is 4i minus -1. So it's 4i plus 1, negative times negative. And if I write it in the form a plus bi, I have to flip it around. 1 plus 4i. And that is it. That is the entire answer. There is a part B that we will do in class. Now, some of you guys might see that we're going to have to do a little bit more distribution on this one, but we'll do that in class together. A quotient is a little bit different, okay? A quotient is a little bit different, so I want to actually do the rest of this in class with you tomorrow, or next time that I see you guys. So make sure you have these notes written down. Go back and rewatch it, because I is a crazy, complex idea, complex number. It's an imaginary thing that we're actually making real. We're writing down now. So it's kind of a crazy concept. So make sure you understand the bit that I've shown you here. I'll explain it a little bit better next time in class. And other than that, I hope you guys have a good day. And this is Kistner out.